Well, it's my great honor to be here at the first edition of the AI Inspiration Sessions hosted by VAIA. So I think we had several of these talks within Ghent University for the past year, and then mostly they were very specific. And I guess that in the future of this series, that will also be the case. But I'm often asked, because of the roles I have, to also move towards maybe some kind of vision, what we really do want and how our universities see generative AI. So since last year, Ghent University allows students or even encourages them to use generative AI during their education. But I guess it's very important to wonder, like, what are we going to do with this? And this is a difficult topic because, of course, the area is moving quite fast. So I made this talk to maybe move in that direction of some vision that we have on what is good and what is bad and what should we be doing with it. So first, a little bit about me. I've always been interested in computers and mathematics, especially randomness since childhood. In my secondary education, I tried to automate some of my exercises for mathematics and physics using BASIC, which is the language that we were using in DOS just before Windows. Then I studied computer science with a focus on algorithms, including machine learning and data mining algorithms. I did my PhD in Finland at Aalto. Then I came to Ghent as a Marie Curie fellow, and in 2020 I started as a professor. And what shaped me was that I worked between 2021, when VAIA was founded, and 2023, until December 2023, as an academic advisor creating course materials there. But during this time that I worked there were, of course, some profound new things that happened in the field of AI. Namely, we discovered that generative AI modeling techniques could be used to make foundation models, as we call them. First on images, then text, then also audio and video. And these were actually very useful in practice to generate new variants of what already existed. So then in the early 2020s, there came the rise of foundation models, and end of 2022, ChatGPT came online. So we found chat-based systems started. And after that, also the impact started increasing. It was the fastest adopted tool ever made. A lot of hype was perhaps created, also ethical problems. And what I observe nowadays is that, even within our universities, there is some polarization. So some people are super enthusiastic and think that this is the biggest thing ever that happened already. And we're going to have, the field is moving very fast. We are going to have artificial general intelligence soon. And on the other hand, there are a lot of people that say, well, due to all these ethical problems with the creation of these systems, the use of these systems, I want to stay very far away with it. So the question is, should we be trying to find some middle ground? Now, it's very difficult to make predictions in general. And especially about the future. And also here, because the field is moving, it's a challenging subject to give such advice on, yes? But I think now we have arrived already at a point that we have sufficient information to make some decisions, and it's fairly stable, so we can talk more substantially about what we should and should not do in the near future. So the purpose of this talk is the following. I'm going to both review the ethical aspects and wonder, is Gen AI mostly hype and just something to ban from our lives? Or is AGI a coming reality, and should we be preparing for that? And if it's neither, then what is it really? What can it do? What can it not do? Can we view that at a higher level and make some expectations about the future and then make sensible decisions? So to give you the result of my presentation already, I'm going to argue that there are indeed many reasons to minimize the use of current state-of-the-art systems like ChatGPT. At the same time, it is perhaps the most profound technology that we have ever made, and it is going to change our lives to the better also in the near future. Increasingly so. So I think we need to be more active on adoption and mastering this technology because it's very useful for any type of knowledge work that we do. And of course, especially in research, that is a lot, but also in administration. And then last but not least, I think actually least probably in education, because education is mostly not knowledge work. Okay, let's go to the hype first. So immediately after the launch of ChatGPT in 2022, it became a very popular tool to use. And then Sam Altman, the CEO of OpenAI, he started spreading these stories, but also, other prominent people in the field had very similar opinions. We are actually close to artificial general intelligence, so making systems that outperform humans on certain tasks in a very general way. So now artificial general intelligence is not defined at all. Even artificial intelligence might not have a proper definition. But Sam Altman here gives a definition, namely that AI systems that are generally smarter than humans. Now, back in the day, well, so there's here the sentence benefits to all of humanity. They were way more open than they are now. Let's review some other aspects of this hype. So this is the a figure from the AI 2027 report that came out early this year, which sketches, not based on hard data, but based on developments that people see in the field, that in the year 2027, what is going to happen is most of programming will be obsolete and we'll have fully automated coding systems. These can then do research and improve themselves, so that soon after we'll have superhuman AI researchers, remote workers, super intelligence emerges. This will create huge societal problems, etc. Now, although this document is recent, I find many aspects difficult to believe, and it's also not based on hard data. However, there are more in-depth studies that actually look at, for example, benchmarks and performance analysis of generative AI systems. One of the most famous ones is a report by the Meter Institute that appeared online earlier this year. And they took the following perspective. So they are looking at software engineering tasks or programming tasks. And then they have a benchmark where all of these tasks, they have varying difficulty levels for human software engineers. So they made estimations of how difficult each of these tasks that appear in this benchmark are for human software engineers. And then they put a number on that. So on average, how much time would it take for a human to solve this task? And then they measure this also for AI systems that have appeared from 2019 onwards. So here in this graph on the x-axis, you see the release date of these different models, starting with GPT-2, which was also from OpenAI, GPT-3, 3.5, which was the first model included in ChatGPT. Then GPT-4, that created quite a performance advantage. And then more recent models also from other providers, such as Anthropic. So on the top right, you see Sonnet 3.7. They also have a more recent version of this graph, and you see that indeed the recent models, such as Claude 4 and GPT-5, they are in line with these expectations. So notice that on the y-axis, it is a logarithmic scale, yes? So that means a straight line here means that there's an exponential growth here. Their conclusion is that the capabilities of these AI systems is doubling every 7 months, which is of course very, very fast, yes? And this has been the case for the past 6 years, they are saying. So that is quite an interesting conclusion. Extrapolating this would mean that by 2030, these AI systems can do in minutes what would take a human software engineer a month to do normally. Now that is quite groundbreaking, because that means that software engineers will mostly be out of a job if we truly automate all this away. And that's not an easy task. So you can also easily generalize this to lots of other knowledge work problems. Now, I think there is no doubt that the capabilities are actually growing exponentially, but the question is, with what base rate are they doing so? An analogy that I sometimes make is that when COVID broke out, the first estimates of the doubling time were 1.5 days. Later, we realized that actually the disease did not spread so fast. There were many factors influencing this estimate, namely more broad testing. Testing became more available. People went to the doctor more often, and it was rather something like a week and a half. So 10 days rather than 1.5. So estimating this base rate is very important. We don't have any more realistic estimates than what is in this report, but I think it's very much overestimated. So in reality, what we are seeing that we had many tricks. So these models, they mainly rely on attention, and then we have other things. So we gathered more data, we have more compute. There are other tricks that you can use to make better systems, which we already knew about, that have now been implemented. And I think, yeah, GPT-5, it was delayed before its launch. That was maybe to be expected because now we are a bit at the edge of what we can do. So I think in the future, we are going to see much less fast progress. And I think there are many people that agree with that. So at the moment, we really don't have any techniques anymore that we already knew about that can be implemented right away to lead to the next generation of systems that would fulfill this curve. So although I kind of disagree with the conclusions in this report, and I think it's not going to happen every 7 months, but the doubling time will be much slower. Something in the slower than Moore's law, which holds, for example, in computing for a long time, where the doubling rate is every 2 years. So another perspective to see that, okay, there's something really going on here is, well, investors. You might argue they're right because there's some real value in this. If you look at NVIDIA, who makes the chips that are used to train AI models, their value since 1999, when they were already making graphics cards, has increased a lot, yes, especially since 2022. So there are a lot of people that see huge value in these systems. Now let's move to the other direction. There are a lot of problems and risks with these generative AI systems or chatbots. So namely, a lot of things are known about how OpenAI made their models. So they scraped the entire web. They ignored everybody's copyright and a lot of privacy also. So anything that they could get their hands on, they put it into their systems to make these models. This is also known very well for the models made by Meta, for example, who make open weights models. So they publish their models in full, and then it's much easier to do this type of analysis and research on it. How were they made to kind of reverse engineer them? But I assume that's also true for Google and Anthropic, who made Gemini and Claude. They've hired people in poor working conditions to label this data or filter it, often also without psychological counseling, for example. I think it's very well known that there is a very high energy cost and other resources to create the hardware and also to run these systems. They are unreliable, so they suffer from giving false information sometimes. And this is a problem that's not necessarily going away anytime soon. So here's, for example, the top right table 4 that I'm showing here is from the model card of O3 and O4 when it was launched. So this information comes from OpenAI itself. They show that O3 and O4 give longer answers. So O3 is their full model. O4 is a smaller, more efficient one. If you compare O3, which is the new model, against O1, their previous version, it's both more accurate, but the hallucination rate also went up. So it's giving you information that is actually false. More than the previous generation. So they haven't solved this, yes? These systems are non-deterministic, so that means that reproducibility is an issue. They suffer from systematic biases. And then, of course, also things that are immediately relevant to us. There's an increased risk of cutting corners. So, for example, for students, if they write essays, etc., they might be, well, all humans are a bit lazy. There could be a reduction in quality. You can more easily get away with things that and get a good appearance, so it reduces your alertness. And if you're not using it deliberately, it can affect your learning. So there's all these other problems that I will not go into detail just to save some time. I will argue that AI is often compared to the Industrial Revolution, what is happening. But I think that's a bit of an odd comparison, because in the Industrial Revolution, we had actual manual labor replaced. And of course, force and manual labor, it's kind of obvious and very well understood, also from the physics perspective, while here it's much less understood. But information technology, so both gathering data, enabled us to understand the seasons and develop agriculture. Then we had the more recent developments that we can communicate across the globe while using the book press or directly using telegraph, telephone, etc. So our communication systems have developed, and all this information technology, it helped us to grow and understand more and more about the world. So I think it's a very different type of technology, and hence it's more impactful. So I think it's something that we cannot miss out on. So AI is not like crypto or quantum. It's both already widely applicable and present now. I believe that it will redefine our relation to data, meaning that all the sensor readings and measurements that you do from lab tests, etc. So data is basically at the raw level. Information is when you process that, you find patterns in it, or facts, if I may use that informally. And then finally, something that we often refer to as knowledge, which is reading between the lines. So we really need this technology to make the ever-growing body of knowledge more accessible and useful. We want to specialize further and deepen our knowledge of all these aspects of society, but we have our own cognitive limits. So that means that if we gain more and more knowledge, relatively, we're going to know less about everything else. That's just a truth, and AI can help us reach that step, because we don't need to memorize everything anymore. But what we can do is get the right information at the right time at our fingertips. So it's plainly the next step in the knowledge economy. So how I view current AI systems is as follows. After this, I will move to a specific study that I did previously with some collaborators, and then advice on how we are going to use this for education, operations, and research. So how I see AI is basically they are really large databases of everything ever written, and that you can query in natural language. And then they are advancing because there's always more training data being put into it. But these databases are fuzzy. They don't know exact facts. They have no way of storing them as such. So the answers become a bit random. And you have to always read a little bit between the lines. That does allow them to also develop to some degree new insights. However, be careful, because they don't really do any type of formal logic, mathematics, or reasoning. What is slowly emerging that they are capable of using tools. So that means that, for example, if you ask them to solve an equation, they would write it out and then call Mathematica or use Python to come up with an answer and then feed that back. But the neural networks themselves, they don't operate using actual logic or mathematics, which is, of course, ironic, because technically they are operating fully on a mathematical system. They also don't learn actively. So people often think that if you chat with a system, it's going to learn directly from what you input there, but that's not the case. What they do is make a profile of you and then feed this without you seeing it to every prompt that afterwards you fire. So it's like the system instructions. It is their engineers retraining or updating these models based on information that they think is useful to feed to these systems. And finally, people often ask questions for systems to explain themselves, but they have no such capability truly, because they do not get access to how they arrived at a result. So they have no form of introspection. I think it's important to understand that now we're at the point that there are no fundamental architectural innovations that can be brought to practice anymore. So the capabilities will remain mostly the same in the near future. But the efficiency gains, for example, the Google Gemini systems especially, they became orders of magnitude more efficient, which is reflected in also the price of using them immediately. Those are still moving very, very fast. I think there is a lot of value in more complex use of these systems. So to briefly tell you about the study that I did last year, so together with Alex Rogiers from my research group, and then it was a collaboration with Statistics Netherlands, and Gadir is a master thesis student of last year who graduated very successfully. So the question was, can we, using natural language prompts, provide people with answers in the form of charts using the Statistics Netherlands data. So this is curated data, but it's spread over many tables. So what the AI has to do is find the right information, then write code to turn this into a visualization in a meaningful manner. Of course, the x-axis, y-axis, all the labeling should be correct. It should be the right type of chart. So it is a fairly complicated setting. What we can see in table 2 here is that for all these systems, so we use small ones, large ones, the code generation is quite good. However, the visual and data aspects, they are often not very good. These are scores out of 10, but 75% is actually maybe not a very usable score, because that means it made some very fundamental mistakes. So we can make this to work by using a feedback loop, which is nowadays available as thinking mode. So what that means is that the AI is going to look itself at the answer that it gave and at the prompt again that you gave, and then consider whether it actually did a good job. And then the second thing that you can do is provide a lot of context. So in this case, we gave extra instructions about the formatting of the data, some basic principles on how to do good visualizations, because even though it has read textbooks about it.
Even een melding dat de tijd bijna op is.
Yeah, I'm going to try to wrap up. So you have these feedback loops, and here we give basically a context, so a very detailed instruction of how to actually approach this. And that managed to actually bring it to a very usable level for a complicated setting. So I have some advice for what we should do with in education. So there are several immediate problems that we need to address. Yes. So first and foremost, there is the validity of testing, which created lots of problems at our university. So that means that you should really be mindful of the fact that you should prevent cheating. Yes, if you want to test whether students have learned certain skills, make sure that it's in a controlled environment, or that you know that the AI cannot do this. I'm also worried about the loss of social engagement, both between students themselves and students and teachers. There's the need to keep up. So there's changing skill needs. So we need to work on that, obviously. Both teaching generative AI, I think, which is relevant to most students. But generally, I think in education, we will be teaching mostly in the same way, and it's useful only for specific things. Note that some use is high risk, yes, according to the AI Act, for example, automated grading, etc. That is, you need to be very careful about what you do, and there are extra legal requirements if you want to use systems for these kind of things. So for operations, well, automation is faster, cheaper, and more accessible than ever. It is possible to automate processes that weren't automatable previously. However, it's not easy. So linking this back to the study that I just showed, often just firing a simple prompt doesn't solve your problems, but you need to design a process on how to use this, giving more context information, and of course, evaluate also what the quality of the results is. Going to the final part, I think what we see is that in research especially, people are doing a lot of different things. Not all of them are great because they might have reduced quality. Like if you use it to do part of a review process of a paper or something, well, the opinions vary. A lot of people are using it already actively for such tasks. Well, it allows you to gather and process much larger data sets than ever before, and also to maybe do the analysis in a richer way. So to wrap it up, I think we are going to see most impact here in the coming 2-3 years. Also with how we deal with research papers in the first place. There will be a reduced trustworthiness of scientific publications, and we will need to find ways to deal with that. Okay, thank you. I hope there's still a little bit of time for a few questions.
Thank you, Jeff. Dankjewel, Jeff, voor dit super interessante praatje.